getting ready to start on the next project here in the shop, and what I have is some components that I have to machine for one of my viewers. His name is Brian Simmons, and Brian owns a wood lathe, and these are going to be some parts for his tailstock off this wood lathe. And what I'm going to be making is a lead screw, a nut, and a retainer. And we also have, this is the quill off of that tailstock right here. We're going to be modifying this. So the nut, this is the drawings that he made up right here. I got to make this nut, and we're going to modify the end of this quill and bolt the nut onto the end of that. And we're going to be machining the lead screw, which he's got drawn right here. That'll be matched up to the nut there as well. And then we also have a retainer. That's this guy right here, and this is going to be bolted to the back of the casting of the tailstock itself. And he'll be doing that. He'll be bolting that on. So how he explained it to me is that this particular tailstock for this machine, and I got a couple pictures there I can throw in that he provided. Manufacturers, just have the tailstock board where this slips in there, and then on the back side you've got a through hole that's drilled, and then the screw goes through, and it's just metal on metal where the screw bears against the casting. And so you don't have a lot of accuracy right there, and probably quite a bit of friction. So he's wanting to improve this design so that it works more efficiently and is more accurate, So he's adding a proper nut and a ball bearing to this assembly right here. And hopefully this will make this operate in a much nicer manner. So we've got some materials that we'll go over that we're going to be using. We're going to start with the nut. So Brian provided this piece of bronze here. I have no idea what type of alloy this is. No clue what this is, but he had this, so we're going to use this for the nut. All right, and then I'm providing the material for the lead screw that we're going to machine. By the way, this is going to be a 3/4 6 left-hand Acme thread that we're going to be machining on this. And I have a tap that we're going to be using for the nut. This is the nut that we're going to be, this is the tap we're going to be using when we're making the nut. It's a 3/4 6 left-hand Acme. And I borrowed this from Keith Rucker, Vintage Machinery. So thank you, Keith, for that. We're going to be using that to machine the bronze nut. So on the lead screw, I've got this piece of stress proof right here. This is 1144 stress proof steel. And what I really love about stress proof is that it's free machining. So it machines nice. You can use high-speed tooling on this all day long. It makes just a real nice, easy chip, and you can get good finishes on it. Plus, it's a good, strong steel as well. So that's a good material to machine this lead screw out of right there. All right. So we also got to make a retainer, and he asked if I could machine the retainer out of some stainless steel. This is going to be the retainer right here. This is the piece that's going to be bolted to the back of the tailstock. That's going to house the bearing right there, and then the lead screw will be going through there. And on the back side right here is where the hand wheel is going to be fastened onto that. All right, so for that I've got this piece of 303 stainless steel, and so we'll use that right there. 303 is nice because it's designed to be more easily machined. As long as you don't have to do any welding. This is great for machining parts out of stainless steel, but you don't want to weld on 303. So that'll be good for that. This is just another drawing that he sent me with a couple more dimensions that he had originally left out. He also wants a through hole going all the way through the lead screw. He says he wants a 3/8 hole, but he'll accept a 5/16 or even a 1/4 inch, depending on what I decide to put in there. But we'll see about putting a 3/8 hole all the way through there. Okay, so I think that's it. Let's go ahead and jump into it. We'll start with the nut and get that done first. We're going to be using our 6-jaw chuck for probably most of this right here. So we'll go ahead, and what we will do is we'll do our machine work on one side, face it, turn it, and then we'll either part or cut it off, and then we'll chuck it back up and do our bore and then tap this piece, okay? Adjusting the center height there. There we go. I switch these tools back and forth between the two lathes, and they're not perfectly on center with each other. This is going to act like free machining brass here. I think that's what it is just free machining yellow brass. If that's the case, that's going to be nice. It's going to be easy to tap. All right, I've got a 0 set right here. That's going to give me plenty of clearance here to get in there with a parting tool and machine our component. We're going to be taking the flange diameter down to 1.5 inches. We're starting with a 2-inch piece of stock. See what the chips do. I gotta grab my earplugs. I'll be right back. We're going to take the rest of it on down to 1 inch in diameter now. Just slowed the feed rate. That's why the chips are looking a little different there. So we're going to make this 1 inch. So we got one more cut here to make. All right, we got 49 thousandths to bring it down to 1 inch. All right, so we're getting ready to put our tap hole size in this nut. Okay, so we're going to be using this 3/4 6 left-hand Acme tap. I'm going to be spinning it in there just like so. But we got to figure out what our hole size is going to be for this. Okay, this isn't like your standard taps that you can look up on the chart and they have them listed up there. You usually got to figure these out for your Acme. So we're going to be using the 20th edition Machinery's Handbook for this particular job right here. And so for the 20th edition, you can go to page 1349, and they've got all your information right here in this chart for your external and your internal threads that tell you how to calculate whatever you need to know. All right, now I've already done this off camera. I've already got all the information right there. I figured out what the pitch is, all right, and then figured out what our bore diameter is going to be for a 3/4 6 Acme thread. I've got it figured at 0.589 inches. But this chart right here tells you what you need to know. So I know you can't really see that on camera there, but right here it says minor diameter, minimum diameter is K, and K says basic minor diameter is the diameter minus the pitch. All right, so how do you get the pitch? Well, right here it says the pitch is 1 divided by the number of the threads. Okay, so 1 divided by 6 threads per inch equals 0.166. So that's going to be your pitch. So to get your minor diameter, you take the major diameter, which is 3/4 of an inch, 0.750, subtract the pitch from that, and that's going to give you your diameter right there. But you need to add a little bit of clearance to that, so I added 5/1000ths of an inch, and that gives me 0.589 for the bore diameter for a 3/4 6 Acme. Okay, so any of that information that you need to figure out is going to be in this chart right here in the Machinery's Handbook though. Okay. All right, so we're just going to spot this, and then I'm going to use a 9/16 drill bit of 0.562 to drill it just a little undersized. And then what we'll do is we'll part it off, we'll rechuck it, and then we'll bore it to make sure that the bore is on size and concentric to the OD. I'm just using the center drill just to make a spot, just a divot, just like so. That's for the drill bit to center itself up on. I'm not going to pilot drill it. I'm just going to go straight with the 9/16. This is a good drill bit. Still has a factory grind on it. That soft brass, it's not really that good to push a drill bit through a hole that's already been drilled through there. It tries to catch the drill bit and snatch it and pull it up in there. All right, here we go. All right, there we go. Now we'll rechuck it, face this side to the proper thickness, put our bore through there, and then we'll tap it. All right, we're going to go ahead and put it back in the 6-jaw here, and we're going to bore our bore to size, and we're going to face this to length. We'll do our face first here. All right, show you a couple things that we're going to do. Let me get that space. So what I want to do, I'm going to use this the Starrett anvil mic right here to be able to get in here and measure this flange. This would be a good job for it. A little bit closer tolerance right here on this side, the fixed side of the mic, to be able to get in there and be able to measure that. We can get right up in there in this part of the jaw and measure that. So we should be able to leave that right about there. Go ahead and get it chucked up. I'm going to set up a 3/8 shank carbide boring bar, and what I'm using is this bushing right here. Just a bushing with a 3/8 bore that's going to hold the bar. And let me show you this little tool we're going to use. So this is a nice little carbide boring bar that was given to me by Harvey Tool. It says a 0.360 minimum bore, 2-inch maximum depth. Okay, so this is a solid carbide boring bar with a 3/8 shank. All right, so we don't have very much to come out of this anyway, so we're going to stick that in there like so. And level that up, and I'll tighten the set screw down there to hold it in place. We got approximately 63 thousandths to come off that face there. We'll set up my edge carriage stop right here. I'm just going to get in there and read it. 25, 35, 40, 42. So we got 42 thousandths to come off. We wanted to make this 1/8. Looks like we're right there. Maybe I don't know what, 4/10 over, 125. Close enough. If you recall, we're going to make our bore 589. I'm just getting a measurement to see where our drill drilled it. Should be around 9/16. So we're at 565 right now. 60, 70, 80. So we got 24 thousandths to skin out of that. We'll see where we're at, and we'll take one final cut in there to bring it out there to our 589. Do this a couple times just to double check. Alright, so we're at 573 right there. This should leave us with about 16 thousandths. And that's a clearance size, so we're okay if it hits a little bit over that. It ain't gonna kill it. Alright, we're going to tap this thing right here in the lathe, just like so. I'm going to start, I got a drill chuck in the tailstock right here. Got my 18N, and we're going to use this big boy tap guide made by Logic Industries. This one's a nice strong center, and that'll hold that tap up. I'm going to put one little dab of anti-seize right on the tip of it. I'm actually using this Blue Molly anti-seize right there. Just one little dab right on the tip. Alright, and that'll help keep the center of that tap lubricated. This is going to guide the end of the tap just like so. Alright, put that in there, get it snug, that way it'll keep the tap nice and straight. Now I'm also going to be using some Tap Magic for aluminum for this. This also works for brass. I'm going to go ahead and get a little bit on there just to kind of wet it down. It should tap pretty easy, but this Tap Magic should make it even easier. I am going to try my alligator wrench for this and see if it works. So far so good. It starts off easy, but it's going to get a little tougher as it goes up in there. And this is a fast moving thread, so we got to make sure that we keep our center pushed up in there nice and snug. Helps keep it nice and straight there as well. Now, I'll say that a lot of guys will try to use the technique of power tapping it by dogging the wrench off to the carriage here. In this case, we would be doing it over on this side since it's a left-hand thread. But in my experience, I've had problems damaging and pulling the threads out by doing that. It seems like whenever you have a wrench here like this and it's dogged off onto the carriage and this is rotating, it's applying pressure here on this. It's pushing up on it. You're not seeing it as it's happening. As this is going in there, the threads out here on the tap are just cutting the threads on the inside of that part away. I would rather just manually do it. You can get a lot better feel of what's going on by doing this by hand. If you're just doing one of these like I am, this is perfectly fine. Now if you're doing a bunch of these for production, then you're going to want to come up with a better solution to get these done a lot faster. I completely agree. You hear that squeak? It's starting to get a little tighter. So I'm going to keep it wet with this tap magic there. Put spring tension back on that center. I'll put my gloves on because I really don't like the way that tap magic smells, and when it gets on your skin it just seems to stay there. Such a short chipping material, this brass, you really don't have to back it out and clear it like you would a piece of steel. We're making progress. I know it don't sound pretty, but we're getting there. All right, we're just going to run that tap all the way through there. I think we made it. I think we made it home. Oh yeah. Okay. That last little bit, just going to need some help there. There we go. All right. All right, we'll go ahead and unchuck it, take it out of there so that we can remove the tap. First look at our finished Acme internal thread there. I think it looks pretty dang good. I'll get her blow it out and we'll check it out a little bit closer. I need to do something with that burr there on that side, but I think we're just about done with the lathe work, guys. Alright, here's a good look at the nut after we threaded it. By the way, I was going to point out that I did go back and I chamfered this corner and I polished this face. There was a little bit of a burr right there where the thread started, and I just polished that out with some Scotch-Brite. See if we can get you in there. See if it'll focus so you can see. Looks pretty nice. So this end right there, you can see we got a pretty bad burr coming out on that thread right there. So I need to get in, so I need to face this off right there. But I'm gonna wait on this. I'm gonna come back to it because I've got another small 3-jaw chuck that I can put on the lathe and take the top jaws off, and it'll allow me to chuck this right here with the flange behind the jaw and easily get in there and face that off. But I don't want to take the 6-jaw off yet because I got some other work I want to do. So I'm going to come back to this later and do this burr right there, and I'll show you all that. Okay, so we'll revisit that. So from here we need to go to the milling machine, set it up, and we need to drill a 3-hole pattern in this flange. Okay. I'm going to use my little low profile chuck right here to hold this piece and drill our 3-hole pattern in there. First thing I'll do to get it centered up is to kind of close the jaws up, and we're going to use my center point, and that'll get it kind of close. Alright, that'll put us close for indicating right there. And what I'm going to use is, instead of putting the workpiece in there, I will take this rod. This is a 1/2 inch diameter piece of Rex 95 tool steel. I'm just going to put that down in there like that, and we'll go ahead and we'll just indicate this piece right there. So that had me about 10 thousandths away doing it that way with the center point, I mean. Kind of like that right there. All right, we'll call that 0 on our digital readout up here. Should chuck it up nice and square. We're just drilling through the flange there, so we don't want to touch the jaws with it. It's just very little drilling that we're having to do. So let's go ahead and compare it. Let's see if we're centered up. All right, so we had what, about a 1. There's 1/1000th difference, and that's probably from unchucking and putting another piece in and chucking it back up. So I'm not going to be too concerned about 1/1000ths on that right there. So we are going to roll with it. All right, we'll go up here to our DP 500 pitch circle diameter. All right, we're going to go to diameter. So our diameter is going to be between our 1 inch diameter or 1.5 inch diameter. Split the difference there, so it's going to be 1.25 inches. We're going to do 3 holes. And we're going to do a 0, we'll just do a 0 approach angle. And go. We're going to be using number 4 screws to mount this into the quill. So that's one of the screws right there, just test fitting it. So we'll get the holes drilled and we'll come back and do the counter bore. is come down on that stop. Now I'm going to check it. Need a little bit more. Just crank the knee up a few thousandths at a time and then run the quill down onto the stop. Alright, we're looking pretty good right there. We got a little bit more to go. We're going to start cutting into that outside, which is what I was afraid of. It's looking pretty good, right about there. I think we're probably gonna call that. We'll see how much more we got a little bit more in that bore there. We can still go. Alright, I'm thinking that's looking good right there. It should be flush with the surface right there. So now we got our stop set. We'll be able to go to the other two and countersink those to the same depth. Good. All right. All right, guys, we got this finished up. Lead screw nut is done, all except for this burr on the back side right there. And as I said, we're going to go back and revisit that once I put my other small little 3-jaw chuck on. I'll face that off there and polish that up. Okay, but I've got other work to do. I don't want to take the 6-jaw off yet, but it looks good. Tap did a good job cutting that thread inside. All of our sizing is right on and our finishes look good, so that thing looks good. Let me show you this real quick. So this was the this is the nut that we just made right there. So next piece in line for our next video is going to be the lead screw right there. Okay, so we're going to go ahead and get started on that. I wanted to do the nut first and get the threads cut in this, so that whenever we start on this, as we're threading this Acme thread, we can fit this thread to the nut, okay, and get them fit real nice. All right, so that'll be the next video. Hope you guys enjoyed and come on back for some more. All right, see you soon.